Thanks very much. So hello everybody, and you're very welcome to a chat about the BSc in Psychology and Mathematics. But before I start, what I want to do is put you to work for a couple of minutes. So I'm going to show you a very short video, and the video relates to selective attention. And what I want you to do is very, very carefully, I want you to try to count the number of times the ball in the video bounces. So let's give that a go. Let me share my screen with you here first of all. And remember to count the number of times the ball bounces.
Selective attention. Count how many times the players wearing white pass the basketball. Passes. The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Christopher Chabris and is copyrighted.
So what that little video showed was how our attention process works in practice. And one of the things that we want to do is try to understand from a psychology perspective how it is that human attention actually works. And that's going to be the basis of the taster lecture that I'm going to give to you today. So I'm going to share with you a couple of slides, and if you have any questions on any of the materials, please ask as we go along, and I can go back over the materials at the end. So attention is a very important part of our human ability to interact and respond to the world around us. And what I want to do is I want to show you some of the thinking and some of the work that's been done on attention from a psychological perspective. But then I also want to show you why mathematics is important to help us further our understanding of a lot of the psychology processes that we've been studying maybe for the last 50 or 60 years. So we all know what attention is, right? Seems fairly straightforward. But when we stop to actually think about how is it that we define attention, what to define a process that happens without us sometimes being aware of it. But we know it has something to do with concentrating and focusing and picking something in particular that we really want to pay attention to. In other words, it's the opposite you're coming in and out. Dazed and confused way of living our lives. Another way of looking at it is attention is the strategy that we use naturally to help deal with information bottlenecks. So all of the information that's coming into us from different parts of our environment. And there are a couple of different components to attention. So on the one hand, we have time, and on the other, space. So time is very simple. It's about sort of updating information or paying attention to new things as they come to us. So as we see or hear or feel new information out in the world that we need to attend to, we have to constantly update our mental processing with time. Space is also important in the sense that maybe we are paying attention to particular things at any moment in time. So you might be paying attention to your screen, for example, at the moment, and something could be going on outside the window, but you're trying not to let it distract you. So time and space are very, very important. And we've developed lots of different experimental methods to help us to measure attention. And again, remember, we're measuring something that we can't really see all of that well. So this is an example of what's called a visual target test. It's a time task where we update information that's in our memory. On the one hand, we're looking at visual cues on a screen, so we're trying to follow the position of a square around a screen, and maybe we have to respond in a particular way, hit a particular key when the square, for example, appears in the bottom right-hand corner of the screen. But at exactly the same time, we're listening to signals, auditory signals coming in through a set of headphones, for example. And maybe in that particular case, we need to respond using a different key if somebody says the letter C. So in the first trial, as we look from left to right, we might respond to the auditory symbol, but we're not responding to the visual. We're not responding to either in the second example, both in the third example, and so on. So we can measure response times to how quickly we can focus our attention on something. Attention in space that we might want to think about. And the little example that we had at the beginning is a classic test by Dan Simons and Levin. And basically it's about inattentional blindness. So for example, you're concentrating on one element of what's going on in front of you that you don't see the gorilla walk the image and out to the far side. A related kind of concept is change blindness. So I don't know if you've ever seen any of the funny videos or the clips on YouTube of, let's say, a tourist who goes up to somebody to ask for directions, and something happens that crosses through the space of the between the two people, and very quickly the tourist swaps with somebody else. So let's say it's a two workmen carrying a piece of wood. Blocks the ability of the tourist and the person who's helping them to see each other. Tourist quickly changes their hat, changes from a man to a woman. In many, many examples, the interruption has moved away. The person just calmly goes on giving their directions as they have. They haven't noticed the change in the particular scenario. So space is very, very important when it comes to attention. And we also know this by particular difficulties that we've seen in patients with neurological damage. So the way our brains work is that the right hemisphere, or the right side of our brain, pays attention to space across both the left and right visual fields. So everything that we're looking at in front of us. But the right part of our brain pays a little bit more attention to the left-hand side of what we're looking at. The left part of our brain only pays attention to the right-hand side of our visual field. So damage to one side of our brain or the other can cause a problem with how we see in the opposite visual plane. So here's an example of a drawing by someone who suffers from what's called hemispatial neglect. They have a difficulty on the right-hand side of the brain, and they're not very well able to pay attention to the left-hand side. They can pick up a couple of little pieces, the outline of an arm, the left-hand side of a stool, whereas they can pick up a lot of detail on the right-hand side of the visual field, because the left-hand side of the brain is working very well. So we can learn a lot about how attention works by looking at instances where it goes wrong. We also have different types of attention, and this again is something that you'll recognize from your day-to-day life. So divided attention is where we're trying to respond to all sorts of different competing stimuli at the same time. So we might be trying to study, and our sister or brother is playing, a computer game in the front room, and somebody's walking around upstairs or hoovering the floor, and you've all of this competing information coming in, and it's very, very difficult for you to actually take anything on board. Multitasking is another famous example. And there are a lot of people who would tell you actually that multitasking is a fallacy. It doesn't really exist. despite the fact that women are supposed to be very good at it. But what actually we're doing is we're switching attention really quickly between tasks, so quickly in some instances that it feels like we're doing two things at the one time. But in effect, we find that we're not doing either quite as well as we would be if we were looking at it on its own. And when we focus on one thing at a time, what we're looking at there is selective or focused attention. And we can drown out all of the other things that are competing for our attention. And that's something that's very, very important, that ability to be able to control our attention when it comes to day-to-day life. So the examples, the recent examples I gave you there, pay more attention to visual processing, but we can also have auditory attention as well. So imagine you're at a party and you're chatting away to a group of friends and you hear your name mentioned at the opposite side of the room. So it's not that somebody is calling you, but maybe they're saying something or telling a story that you're involved in. And this is something that's called the cocktail party effect. So the cocktail party effect is this idea that no matter whether we're engaged and paying attention to something in the moment, hearing something that's really important to us, such as our name, we're able to pick that up from all sorts of competing noise that's going on at the same time. So on the one hand, we have a lot of research that shows that we're quite good at sort of dividing auditory attention in some ways. But that only seems to hold true in certain instances. So what we tend to do is we tend to rely on things that are easy to tell the difference between. So the intensity of someone's voice, the location, where the voice is coming from, the content of what somebody is talking about. So for example, our name. But again, we've developed experiments where we can eliminate those differences. So for example, we can have the same voice essentially speak two different messages, where one goes into the right ear and the other goes into the left ear. And when that happens, we find it very, very difficult to separate out what's being said in one ear versus the other based on just the meaning or the content of the message. If we then are told to say, for example, pay more attention to the right ear than the left ear, it becomes a lot easier to describe exactly what we're hearing in the right ear, but we tend to lose almost all of the information about the message that's going into the unattended ear. We might be able to pick up, for example, whether it's an actual voice versus, let's say, white noise or music. We might also be able to pick up whether it's a female or a male voice, but that's generally about it. So we have these conundrums that we're trying to resolve when we think about how attention actually works. So when cognitive psychologists really started to examine how attention works in the 50s and 60s, they started to look at, well, what are the different aspects of attention and how we try to control our attention. So they wanted to ask questions like, how can we maintain attention? How can we inhibit or avoid distracting information? How do we switch between attention on one task to another? As the research developed, and particularly as we got to the sort of the late 80s and the 90s, where things like MRIs and imaging arose and became, I suppose it became easier to look at what's going on in the brain while somebody is alive. And while you know they're performing, let's say, different experimental tasks while in an imaging scanner, we then began to identify parts of the brain that might be involved in different aspects of attention. And very quickly, it became clear that there isn't one particular part of the brain that is labeled attention. So this is where, you know, all our control of attention stems from, that actually it's spread out across different parts of the brain. So then it becomes important to break attention down into these smaller types of tasks and try to see, well, is there a specific part of the brain that's important for concentration, for focused attention, versus a part of the brain that's good at switching between different tasks very quickly. And what we learned, if we take the ability to maintain attention, for example, what we learned is that there's two ways of doing this. So there's what's called the top-down or the voluntary way of maintaining our attention. So this is very conscious, it's very deliberate. Top-down is the idea that it works from our goals, our mental control over our processing. So we might decide, for example, I'm very interested in this subject, or I'm very interested in this film, and I want to pay attention. So we use our mental abilities to actually focus our attention on a particular area. Attention could also be bottom up, which is called reflexive, and that comes more from our kind of physiology. So we could be alert, happy, motivated, engaged, and even though this maybe wasn't a topic that we knew an awful lot about or had thought about much in advance, we found that there's something about it and about our kind of general state of being that is keeping us engaged. Another way to think about this is where we fail to maintain attention. So top down, we might really want to listen to a particular lecture, but bottom up, maybe we didn't get much sleep last night, we're very tired, and despite our best efforts, our concentration just isn't there, our focus just isn't there. So we've been able to develop models or taxonomies of attention by bringing everything that we know about damage to the brain, problems that people have with attention, mapping or imaging attention as people carry out tasks in a scanner. And we've been able to see that actually there are this top-down and this bottom-up approach to attention. We also have something that's called external attention, which is where our attention is captured by different things in our environment. So we might see something new or novel, and we automatically take a look at it. Whereas internal attention is much more about that determined, conscious kind of process where we are motivated to attend to something. And certainly our goals are very important in both of these cases. So our attentional goals might be to pay attention in a lecture theatre, for example. But if we're out for a walk in the park, we might be much more open to novel experiences, novel stimuli in the environment. We also then can look at ways of, well, how do we go about inhibiting things that are distracting? Is there, are we predisposed? Is there a certain biological characteristic in humans that controls our attention process one way or another? Is it something maybe that we've learned over time? So there's a really classic test, and there's lots of examples of this out on the internet. So just Google Stroop test and try one or two of these yourselves at some point. But this is a really neat test that looks at the primacy of reading. So for example, we are taught to read, and we do so much of our interaction in modern life around reading that we often favor reading over any other part of a stimulus that we're looking at any point in time. So let me demonstrate this with an example. So what I want you to do, I'm going to show you a couple of slides, and I want you to just say what color the ink is in the word that appears on the screen. So practice yourselves. So say out loud what the ink color is of the different slides. So here's the first one. So the ink color in this case is red. How about this one? And what about the next one? So what's going on here is when we see the word red in red font, there's no particular issue with this because the color and the word that we're reading are synonymous with each other. So there's no incongruity or no mismatch between the two. But when we get to the next slide, we're seeing the word red, but it's printed in yellow ink. And what you find is that, particularly where you run a number of these tasks over time, people will make mistakes. They'll read the word red and they'll say red, even though they know they're looking at the color yellow. And it can also extend to things that we have a semantic connection with or a knowledge connection with. So we expect a lemon to be yellow, for example. And again, sometimes when people see the word lemon in a number of these tasks as we're going through them, they automatically say the ink color yellow, whereas in fact it's written in blue. So it's a lovely little task. It works with words and images. And I would encourage you to go and have a look at it on the internet later this evening. And then the last part of, I suppose, the way we manage attention is how we move or switch attention from one area to another. And probably the easiest way to kind of visualize or think about attention at the moment is to think about it as if it was a spotlight or a torch. So imagine you're in a room and the lights have gone out, and you turn a torch on and you move the beam backwards and forwards across the room. And you can see different aspects of what's in the room depending on how they fall into the beam of light. And as you move the beam around, you start to see different parts of the environment around you. And there is a particular type of theory that suggests that our attention works in a similar way, that as we move the focus of our attention around, we can attend to different things. Again, we have a lovely test or task that we can use to measure this type of switching of attention. So in this particular case, you're presenting visual cues to a participant, and what you want them to do is you want them to respond by hitting a key on a keyboard when they see a cue appear or a target appear in a particular location. So say, for example, they're looking for a square, and they're given a hint, first of all. So the first trial there is what we call a valid trial. So they're given an arrow that tells them the target's going to appear in the top right-hand corner. So that's the particular response that they want to make. They might also be given an invalid cue. So they're purposely told to look at a different place. And in theory, it should take them longer then to see the target when it appears than if they were looking at the right part of the screen in the first place. Or they might get a neutral cue, which is totally unhelpful. It just sort of says, pay attention to all of the screen. And you can see on the graph on the right-hand side there, that valid task, so this is the rightmost point, 80% of people get valid tasks correct, and much more quickly. So the y-axis there is response time in milliseconds. So the higher the number, the longer the response time. So people are much, much better at responding when they're already looking at a particular point on the screen than if they're looking away from that point and they have to disengage their attention to the left-hand side of the screen and move across to the right-hand side of the screen. So that suggests that there are some mental processes that are involved. There are resources that are needed in order to enable us to move from one to the other. So just bringing this together then, we have lots of different theories of attention. And some of them suggest we pay more attention to the physical characteristics that are used, and we attend to the first thing that comes along unless something causes us to switch. And there's lots of support for that. So where we start listening to information in one ear, we can drown out the information in the other. But there are problems as well too. So how does this cocktail party effect, when we hear our name across the room, how does that work if in that particular case? You have theories then that say, well, actually, no, you don't make the selection straight away. You take in all of the messages into your short-term memory, and then based on a particular piece that's of interest to you, you make one response. And you have lots of other theories. So things like the load that's involved, so how difficult it is to process something might influence whether we pay attention to it, or whether there are other aspects of our environment that bind to an object. So let's say the light of the beam of the torch, or a sound that may cause us to look in a particular direction. And although psychologists have had a lot of success at understanding how attention works and building up these initial theories of attention, there are gaps in our understanding from a theoretical perspective. One of the reasons is because it can be quite difficult to measure attention. The mechanisms, the technologies that are available to us, they're improving all of the time. So as we start to use these, we then start to get a huge amount of data. So our problem is less about now, how do we measure attention, and more about how on earth do we understand all of this data that is gathered when we start using things like MRI scans and so on, to build up information about what's going on inside our brains that is related to attentional processing. And this is where mathematics becomes hugely important, because we can build mathematical models of attention that can use these new technologies that we have that enable us to better measure our attentional processes. And this is just one example of a model of visual attention. So the idea here is, we can try to mimic or explain or use information that we have about attention to try and predict how does this actually work. And it's not about describing how attention functions, but also maybe seeing, well, if we build this mathematical model of attention and we put it up against, let's say, a human being, and we have both the model and the human being reacting to stimuli in the same person, how does the model perform in comparison? Similarly, we have a lot of eye tracking studies. So here's another example of how to gather lots of information about the way people are attending to a scene. So here is an example of a recent study where the participant is in a historic setting. It's very much a sort of an architectural setting, and they're wearing what's called an eye tracking device. And what this does, and eye tracking devices can be fit into very neatly into glasses now, for example, and it follows the pattern of where the person is looking. So if you have a look at the screen here, you'll see that although the person's eyes move around different parts of the image in front of them, they focus quite centrally on the image a lot of the time. And when you convert that from the sort of visual gaze in the image on the left-hand side to a pattern of all of the different points of data that they look at on the right-hand side, you can see that there's a lot more processing in the center of the image and in interesting components of the image around the edges. So the arches, for example, across the top, the windows on either side of the building. But if you imagine that all of the pink dots on that right-hand side image there is a different piece of data, you can see how mathematical models are important to try to comprehend all of that data and try to look at the sequence that we move through the different data points and basically build models that allow us to break down the processing that's happening in the brain as we try to understand the way attention works for human beings. So that was a whistle sort of stop guide through the subject of attention. It's a particular topic that you'll see and you'll meet in your cognitive psychology studies, and also when you're looking at biological psychology, so how the eye works and how we interpret objects in our environment around us. And what I wanted to do today was give you a sort of a flavor of something that was very classically from psychology, but demonstrate how mathematics is important to being able to further our understanding. So take us beyond what psychologists can look at in their own right. If there are any questions, I'm happy to answer them now in the time that we have left. I'll also be at the panel discussion that's on at 5:30 today. And you're also more than welcome to email me. And my address is on the screen there at any time if you have a question about the course. So thank you very much for your attention. I hope you enjoyed the presentation.
Thank you so much, Louise. That was absolutely fascinating. Psychology is so fascinating anyway, and so many students are just think, there's such a high demand courses, aren't they? The whole area of psychology, but the different aspects of it are really, and I know the next talk as well, psychology and disruptive technologies, which is another aspect of it also. But we just remind students as well that for the psychology and maths, you will need at least a minimum of a H3 in maths, as well as your points to come onto that course. We don't have any questions in the chat because, oh, we do, hold on, what's this? Which will the course be accredited? There you go.
Yes, so Emma, I can answer that for you now. We're in the process of going through accreditation with the Psychological Society of Ireland. We have, I suppose, we feel very confident that we will be accredited because the course has really been built from our BSc in psychology. That was sort of the baseline that we started working from, and that's a course that has an excellent reputation and has been accredited for over 10 years. So we're actively going through that process at the moment. So my expectation would be that yes, the course will be accredited hopefully between now and the next academic year.
Excellent. Okay, so that answers your question there. And I don't think, yeah, that's it. Yeah. So that's the only question that we had for yourself there, Louise. So listen, we'll see you later on at the panel discussion. So it might be a little bit after, we're a little bit behind. So it could be about 20 to 6 or so. Again,
that's fine. That's fine. I'll be there, and yeah, I'm happy to answer any questions. Or please do just email me or have a look at our website as well for more information. Thanks.
Thanks so much, Louise. And we'll see you later on.